Alright, so again, we have this first one. If two lines are parallel to the same line, those two lines parallel, this seems pretty obvious. Let's take a look at this next one. If two lines are perpendicular to the same line, then those two lines are parallel. So let's just say that we have A is perpendicular to B, and C is perpendicular to B. Okay, so A and C are perpendicular to the same line. Let's go and first draw B. And if A is perpendicular, we have it meets that 90-degree angle. Perpendicular lines meet at 4 right angles. So we'll call this one A. And C is perpendicular to B. Then C also must meet at that 90-degree angle, right? So A is perpendicular to B. Again, perpendicular lines meet at 4 right angles. And C is perpendicular to B. Go and discuss with your shoulder partner, how could we prove that this is true? How do we know that without a doubt A and C are parallel? Go ahead and discuss that with your shoulder partner. Take the next 30 seconds to do Alright, what are our thoughts? What do we know? Go ahead, Anthony. Yeah, these angles here are corresponding angles, and if our corresponding angles are congruent, then we can say that our lines are parallel. Good. I don't know that we've formally written out the definition of perpendicular lines, so let's just go ahead and throw that. Let's just do that here at the top. Alright, so let's write out the definition of perpendicular lines in case you encounter that in a proof. Again, I know you know this from middle school, but let's take a look at the actual definition. Perpendicular lines are lines that intersect. That's kind of helpful, right? When you need to intersect to be perpendicular. And form right angles. Form right angles. So perpendicular lines are lines that intersect and form right angles. And again, that notation for perpendicular looks like that. You might need to use that in a proof. For example, if we were to prove that second theorem, we would have to first, after they give us that A is perpendicular to B and C is perpendicular to B, we'd have to use that definition of perpendicular lines to label these angles as right angles. Then we can say by the right angle congruence theorem, these angles are congruent, these are right angles, and then we could use converse of corresponding. Yes?
Do perpendicular lines always make 4 90-degree angles?
Yep. Got it. So yeah, there will be the 4 because of the 4 different angles. Yeah. Alright, questions on these two things? Pretty basic, right? So now let's take a look back at algebra from last year. See what we remember from that. Alright, parallel lines have the same what? What did we say about parallel lines from algebra 1? What do we know? Go ahead and go this. Good, they have the same slope. So parallel lines have the same slope. Okay, parallel lines have the same slope. And let's just remember, oh wait, they gave it here. Alright, so remember our slope formula is n equals y2 minus y1 over x2 minus x1. If we have a graph, we can just count rise over run. Alright, now does anyone remember what's true about slopes of perpendicular lines? From algebra 1? Anyone remember what's true of slopes, right? Very good, very good. So perpendicular lines have slopes that multiply to -1, or in other words, their slopes are opposite and reciprocal. Okay, so opposite and reciprocal. If I were to take the two slopes and multiply together, we would get -1. Now, opposite means that if it's positive, you're going to go to negative, and if it's negative, you switch to positive. Reciprocal means we flip-flop the top and bottom. All right, so Reciprocal, if I have 2 over 3, reciprocal means we flip those and it would become 3 over 2. Okay, do we understand what that means, opposite and reciprocal? Questions on that? Alright, and then just a reminder that we can also pull this information, our slope information, from our equation, slope-intercept form. M is my slope, that will depend on. Okay, so if we're given the equation, we can pull our slope from there. If we're given a graph, we can count our slope from there, rise over run. And if we're given the coordinate points, we can actually calculate our slope. Okay. All right, so let's take a look at this next example. It says, are the following lines parallel, perpendicular, or neither? All right. Well, not all of these are in the nice linear or nice slope-intercept form. We see some in standard form here. It doesn't look like any point slope form. But we need to first get them in that slope-intercept form to be able to even identify what our slope is. So I'm going to take this first one here. Alright, so if I subtract 3x from both sides, I get negative 2y equals negative 3x plus 4. Divide by negative 2. Y equals positive 3 halves x minus 2. Alright, so that's my equation for that first one. Now if I do my equation for this guy, again subtract my 6x, I get 4y equals negative 6x plus 12. Divide by 4, y equals 6 over 4 reduces to 3 halves, so negative 3 halves x, 12 divided by 4 is 3. Alright, so comparing our slopes, again, your slope is that coefficient in front of your x. Are these slopes the same? No, so they can't be parallel. Are they opposite and reciprocal? No, we've got opposite, but they're not reciprocal, so they can't be perpendicular. The only option is here. They intersect somewhere, but they're not a special case of parallel or perpendicular. Alright. I want you to go ahead and try B and C there. See what you get for those. Again, find out what each of those equations are in slope-intercept form, and then compare from there. That's very letter B. It looks like you're lacking equations. Equals. Look at the board up there. It should say AS equals negative 4y. Otherwise, when you even have an equation in the first place, I apologize. Apparently, I did not get that fixed before properly. So again, here it should be equals negative 4. You guys didn't even have an equals. Sorry about that. Got another minute to fix that thing. rewrote this equation, we should have gotten y equals negative 2x plus 5/4. Does that sound right? Okay. So what do we get for this? Parallel, perpendicular, or neither? Good. Parallel. What is our slope for this? Good. -2. Our slope is -2 for both of those. Good. Alright, when we rewrote this equation, we should have gotten y equals negative 5x plus 3. Do we agree with that? Okay. And when we rewrote this, we should have gotten y equals, so add our x and divide by 5. 1/5 x plus 2. Do we agree with those two equations? Okay. Alright, so comparing our slopes here, we have -5 and 1/5. Is this parallel, perpendicular, neither? Perpendicular, good. So we again have that those slopes are opposite intercepts. Alright, any questions on those? Really just doing algebra again. Okay. So now let's take a look at using our new theorems. So it says state the postulate or theorem that allows you to conclude that A is parallel to B. Alright, so number 1 says A is perpendicular to C. And B is perpendicular to C. Can we say that A is parallel to B? Yeah. Which theorem are we using that we just did? Go ahead.
Two lines are perpendicular to the same line.
Very good, very good. And we can even see that here. A and B are perpendicular to the same line. We don't even have to mark in the picture. We can see it just from that given information. Good. Alright, so we do unfortunately have to write out that postulate. And we can shorten it down a little bit. So, state postulate allows you to conclude it. Two lines, perpendicular to the same line, are parallel. Shorten it down a little bit. So, two lines perpendicular to the same line are parallel. Alright, now with number 2, they told us that 1 and 2 are congruent. Think to yourself for just a few seconds, what can we use to help us prove that A and B are parallel? Think back, what can we use for that? Alright, what are our thoughts? What can we use?
Converse of corresponding angles.
Very good. So converse of corresponding angles postulate. So again, 1 and 2 are corresponding angles because they're congruent. We say the lines are parallel. Very good. And then our last one's pretty easy. We see A is parallel to C, and B is parallel to C. A and B are parallel to the same line. So again, if A is parallel to C, but B and C are also parallel, and A and B must be parallel. What's our theorem for this guy? Go ahead, please.
If two lines are parallel to the same line, then those two lines are parallel.
Very good. So similar to number 1, again, let's shorten it down a little bit. Two lines parallel to same line are parallel. That's short. Okay, so that's kind of what you're going to see in terms of seeing it in a picture, or how it might be written, that given statement. Questions on that? Really not too bad of topics. Alright, so let's go and flip it over and take a look at the back side. I actually want to go ahead and move down to example 9. So 4, 5, and 6, it's pretty basic. That's back what you did with Algebra 1, count your rights of a run. 7 and 8, that's something we did back in Algebra 1, and again on your summer assignment, we did it the first week of school. I want to take a look at 9 and 10. It says, is line AB parallel, perpendicular, or neither to line CD? And when you encounter these types of problems, I cannot emphasize to you enough how important it is that you label and are organized with your work. That will be very harsh to my grading with this. You must label your work and be organized with it. Alright? Now we know in order to decide if it's parallel, perpendicular, or neither, we need to check our slopes. Right? And here they gave us coordinate points on the lines, so that means we need to find our slope. So let's start off with line AB. So I'm going to go ahead and label my area of work over here. This is all for line AB. That lets me know that when I'm finding the slope, what slope am I even finding here? Alright, so my slope equals, for line AB, 1 minus 2 over 0 minus negative 9, which would be negative 1 over positive. Okay, so that's my slope for line AB. Another way that you could label this note, so I labeled what line I'm working with, and I labeled that I'm finding my slope. If I just see random work negative 1/9, I don't know what it is you're talking about. Another way that you could label this, if you don't like this method, is that you could just go ahead when you find your slope, label your slope as slope of AB. That would work as well, and then go ahead and do your work. Either way, I'm fine with. So again, if you want to use this notation, what you're saying is the slope of line AB, that's fine as well. Alright, so now I'm going to go ahead and do the same thing with line CD. Again, I'm going to label what I'm working with and label what it is I'm finding. So negative 1 minus 8 over negative 2 minus negative 1. So negative 1 minus 8 over negative 2 minus negative 1. Plus positive. So we get negative 9 up top. Negative 2 plus 1 would be negative 1, so positive 9 over 1. And again, you could have labeled this as the slope of line CD instead. Either way is fine. Alright. Now, if the question were to ask you to justify your answer, then I don't want you to just say perpendicular. What I want you to say is perpendicular and how you know it's true. Now here it's just asking you, are they parallel, perpendicular, or neither, so you don't have to give that justification afterward. We can go ahead and say that AB is perpendicular to CD. Do we agree that it's perpendicular? Slopes are opposite reciprocal. So I can say line AB is perpendicular to line CD. But if it asks you to justify, then what could we say? How do we know by looking at my slopes that it is perpendicular? How do I know that's true? It's my reasoning to be able to state that. Go ahead, Ginger.
The slope of AB, of line AB, is the opposite reciprocal of the slope of line CD.
Very good, very good. So that's all you need to say. To justify that's perpendicular, if you've got your work here and it's all nice and labeled, then the only thing you need to say in addition to that is that their slopes are opposite reciprocal. Okay, that's really all that I'm looking for. So if it says justify, then I want you to actually tell me how do you know that means parallel perpendicular. Here it didn't say justify, so it's not necessary. But guaranteed you will have problems where it asks you to justify. I want clearly labeled and organized work, your conclusion, and the reason how you know it. Does that make sense? Questions on what I'm expecting with that? Okay. Alright, I want you to go ahead and try number 10 while we're sitting here. See what you get from number 10 here. So again, find your slopes, label it whichever way you prefer, and compare them for your answer. Alright, for line AB, did we get a slope of negative 1/8? And CD a slope of 8? Okay, so are they parallel, perpendicular, or neither? Good, perpendicular. Two perpendiculars. Good. Any questions on that? This is going to come back into play. So obviously it's in this unit, but when we get to unit 6 with parallelograms, we have to start doing this stuff again, applying it to parallelograms and rhombuses and rectangles and squares. So make sure you get real good with this because it's coming back. Okay, let's take a look at number 11 here. The line with the given equation is parallel to line J at point R. Write an equation of line J and slope-intercept form. Alright, so they want us to write an equation of line J in slope-intercept form. So we want it in that form, y equals mx plus b. Now you could start off in point slope if you want, or you can start off in that form and plug in points and solve for b. Either way is fine. Let's look at what we know about line J. So line J is parallel to this equation here. So if it's parallel, what do we know about that slope? It's the same. So what is my slope here? 1/2, which means my slope for line J must be 1/2. Alright, and it says it's parallel to line J at the point R, which means it passes through point R, passes through this. And sometimes you'll see it says that passes through point R. So if it's parallel to it at that point or passes through that point, would you agree that's a point that's on the line? Yeah, so we're going to be using this point. This is my xy on the line, and we have this slope here. Now again, you can start off using slope-intercept form, but since I have a point and a slope, I personally like to go ahead and use point-slope form. It's already in that format. But again, you can use slope-intercept form here. So for line J, that's what we're trying to find here. I have point-slope form is y minus y equals slope, which we said is just going to be the same. So my slope of J, we said, is going to stay the same as 1/2. Alright, so slope times x minus x. Now let's go ahead and solve. Alright, so again, you can do point-slope form, or you can go back to slope-intercept. Go ahead and you do whatever method you want. I'm going to finish out with this up here. I'm going to go and multiply to get rid of my 1/2. So multiply by 2. 2y minus 8 equals x minus 5. 2y equals x minus 8 plus 3. Alright, once you get yours, check to see if you got the same thing as I did up here. Alright, do we agree with y equals 1/2 x plus 3/2? Got one person agree. Does anyone else agree? Yes. Okay, good. Alright, so again, you could have gone ahead and started off with this method here, or point slope. Either way, you'll get the same thing. If you start off with y equals mx plus b, again, you're taking your point xy, putting it in for xy, 1/2 put it in for slope, and then solving for b, and then put it all back to it. Okay, so for the next 10 minutes, I'm going to have you go ahead and scoot together with your shoulder partner and do number 12 here, and then go back up to the top and do 4 through 8. This is going back to Algebra 1, so pretty much just finish those problems on that page. Alright, number 4, what do we get? Yay or nay?
Yeah.
Yes, good. 5? 6?
Yes.
Now these pictures were a little obvious. Won't always be that way, but good. Alright, number 7, what was my equation? Good, that one should have been easy and straightforward. They gave you everything you needed for your equation of the line. Alright, now 8, it says parallel to y equals 4x minus 4, and then a y-intercept. So what is my equation for this one? Good. So we keep that same slope, and then we use our y-intercept. Questions on those? Good. Alright, and then number 12. What did we end up getting for our equation of the line J? What do we get for our equation? Good.
Y equals 1/4 x minus 7/2.
Do we agree with this?
Yeah.
Very good. Very good. That's all right. Any questions on this? We're going to go and just start the remaining time. You can go ahead and start working on your homework. You can at least get through the first 2 problems. So your homework is worksheet 3. Bless you. Is there anyone that did not get the homework? Okay, so again, go and start working on that.